Okay, YouTube, in this last video for solving for unknowns in right triangles, we're going to introduce the notion of angles of elevation and depression. And often you will find that you have application problems that you're trying to solve that refer to some angle, and we'll call it an angle of elevation or depression. And essentially, I just want to say they're always considered to be positive, and they always relate to an imaginary line called the horizontal. So essentially, if you would see these two diagrams right here, we have some observers in either instance, and we have this imaginary left and right running line that we call the horizontal that is, say, parallel to the ground. And we'll call anything that is an angle of elevation from the observer to some object something that's going up from the horizontal, whereas if the observer was viewing something down, say, from the horizontal, then it would be an angle of depression here. And so I guess this angle of depression thing, I do want to make one real quick observation on this. Sometimes we talk about somebody standing up on top of a very tall object, and this is just not a very good picture. But when we talk about an angle of depression, a lot of people, they say, well, they're looking down at this object right here, and the angle of depression is this thing right here. And that's not technically true, because technically, and you have to imagine maybe their head is not at the height of their feet, but if we were to imagine an imaginary horizontal line, this thing is parallel to the ground. It's parallel to the ground, okay? So our angle of depression is actually this angle right here. And just because it rotates clockwise, we don't call it negative. We still consider it to be some positive angle because it's an application type situation. So if we know this angle of depression and we know that this whole angle here is 90 degrees, that allows us to solve for its complement and find this part of our right triangle situation. So let's go ahead and take a look at an instance where we have an application situation, and all application situations, unless you're given the diagram, you're going to have to sketch your own. So let's set up the situation, talk about what it is that we want to find, and understand what we mean when we talk about angles of elevation and depression. So we say a person who is 5 feet tall is standing approximately 500 feet from the base of a tall structure. If the person notices a 30-degree angle of elevation to the top of the structure, determine the approximate vertical height of the structure itself. So the first thing I want to do is I want to kind of draw in a ground level here, and I'm going to sketch in this person, and nothing here is drawn to scale. So here's my very small 5-foot tall person. Yay! Okay, and there is some tall structure off in the distance here. I'm going to draw it as maybe like a building. I don't know. Here's the door. So here's what I know. This person already, I can tell you, is 5 feet tall. This is something that was already given to us, and this angle of elevation that they're noticing here, you have to understand that they are noticing from themselves, their point of observation to the top of this building here, they have an angle of elevation of 30 degrees. But the thing that you have to keep in mind is that 30 degrees is up from the horizontal, and since their head is not on the ground, you have to imagine that there's really kind of this imaginary line that runs right here, and that our angle of elevation is really this guy right here. It's running 30 degrees up from their point of observation, okay, the observer, which is their eyeballs. So what we have is this tall object here. We know that also this person is standing, for the sake of simplicity, approximately 500 feet from the base of this tall object. So in terms of what we observe here, we have this right triangle. Since what we want to do is we want to find the approximate vertical height of this building. The unfortunate thing, we can call this the height, okay? The unfortunate thing is that when we do this, in terms of our right triangle right here, what we're only going to be able to solve for is the height of the building all the way down to where the eyeball level of this person is, which is 5 feet off the ground. And then we're going to have to kind of amend on or tack on this 5-foot distance at the end, okay? That is to say that h is actually equal to the x height plus another 5 feet. That is what we're kind of saying here. So using our right triangle here, we know that we have some right triangle. We want to find the length of x, which is opposite of our right angle, and we know that the base of this triangle is 500 feet long. Okay, so knowing what we have here, we would say, well, what trig ratio could we set up that would compare this 30-degree angle to the side opposite and the side adjacent? So opposite over adjacent, and in this case we say that that would be a tangent value. So we have the tangent of a 30-degree angle would be equal to x over 500, and this is 500 feet. We're going to go ahead and assume that I'm going to leave the units off of here, but that it's in feet. So to solve for x, we're going to take both sides times 500 here. I say 500, and so we get this. We get that x is actually exactly equal to 500 times the tangent of 30 degrees. Now, Before I get my calculator out and come up with an approximate height here, which is entirely appropriate, notice that we're taking the tangent of a 30, which is one of our special angles in our special right triangles, 30s, 45s, and 60s. So as far as the tangent of 30 is concerned, we are supposed to be familiar with the tangent of 30s, 45s, and 60s. And so I am going to list them out here, but we should always know that the tangent of 45 is 1, the tangent of 60 is root 3, and the tangent of 30 is root 3 over 3 if we're using exact values. So there are two ways that we can handle this here. One way is to say that x is actually equal to 500 times the square root of 3 over 3, which is actually the same thing as putting 500 over 1. We get 500 root 3 over 3, and this is in feet. So this is our exact value, and that is the exact value for x. So technically the height of this building we said is x plus 5 feet. We would say that the exact height of this building would be 500 root 3 over 3 plus another 5, that many feet. So we have an exact value, but in reality, honestly, what we'd be doing here is we'd be pulling out a calculator to calculate this. So going back to my original trig ratio here to find x, we would just say let's take the tangent of 30. So 30, I'm going to take the tangent. So here's our tangent of 30 times 500. So this is the height of x, and that was, again, that was the height of just the top of the building down to the height of the observer's eyes. And we have to add on an extra 5 feet. So if we add on 5 more feet, then we get an approximate building height here of approximately 293 and we're going to go 7. So we say h is approximately 293.7. You must label this feet. And in any application situation, you should always go label what you've just found to discuss the reasonability of this answer. And again, you know, when you look at this, they're 500 feet away, but this is only a 30-degree angle. So this side opposite is obviously going to be shorter than this 500-foot side. And, you know, it seems reasonable that this building is almost 300 feet tall, given that this is 500 feet, you know, wide at the base of our triangle, and that this is a 30-degree angle. Cheers.